Hello, today we are going to study the algorithm of comparing mixed numbers. But first we will remember how numbers are compared. So, if I write down the number 12,345, and I need to compare that number to the number 123, how do I compare it? That is, what are we going to talk about and what are we going to pay our attention to? The point is that the number 12,345 is written with 5 digits. That is 1, 2, 3, 4, 5. And the number 123 is written with 3 digits. How can this number be compared? It is clear that the number that is written using 5 digits is greater than the number that is written using 3 digits. If we have a situation where I have numbers that are written with the same number of digits, well, let's say 1,012,345 and 1,1322. In this case, the number is written using 5 digits, and in this case, the number is written using 5 digits. I am sure you have already compared these numbers and said that the number 1,012,345 is less than the number 1,1322. What did you do? Yes, at that, we compared the first number 1 and 1. They are equal. That is, nothing is given to us by comparing these numbers. But the next number, let me write down 1 equals 1. That's this number. The next number is 2, is less than 3. And then I conclude that naturally 13,262 is greater than 12,345. In the same way, mixed numbers are also compared. That is, if I write down, let us say 131 whole and 2/6, I will compare 6 whole, 2/5. What will I do? Yes, first of all, I will compare this whole part. I will not pay attention to the fractional part. I will compare the whole part. And what will I see in this case? Well, of course, 131 is greater than 6. 131 is greater than 6. So I boldly put the greater sign. So, in order to compare mixed numbers, I first of all need to compare the whole part. And if the integer part of one fractional number is greater than the integer part of another fractional number, I put the corresponding sign. Let's look at the following example. 131 whole numbers, and 1/3 and 131 whole and 1/2. What is happening in this case? The point is that comparing whole parts, I can't put an inequality sign because 131 equals 131, and let's write that down. Therefore, I have to compare fractional parts, that is, I compare 1/3 and 1/2. And using the rule of comparing fractional numbers with the same numerator, I can say with certainty that 1/2 is greater than 1/3. Then I conclude that 131 whole and 1/3 is less than 131 whole and 1/2. This is the way we have to apply in order to compare mixed numbers. Now, let's take another example. Let's look at 6 integers. 1/5 and 6 whole numbers, let's say 2/3. Let's compare these mixed numbers. What do? I'm comparing the whole part. Already I'm not going to write that 6 equals 6. Therefore, I have to compare the fractional parts, that is 1/5 and 2/3. What do I have to do for that? Yes, to bring to the common denominator. Again, the least common multiple of 5. And 3 is 15. And therefore, an additional 3 and an additional 5. That gives me the following numbers. And let us write down immediately as a mixed number. 6 whole, 3/15, and 6 whole, and 10/15. And obviously 6 is equal to 6, and 10/15 is more than 3/15. Then I boldly put a sign less. So this is how mixed numbers are compared. Although when comparing mixed numbers, we can also use another way. We can convert to improper fractions. So, I'm going to put 6.1 here. That's 31/5 and 6.2. And I'll convert that to an improper fraction. The result is 20/3. So I will need to compare the fractional numbers, 31/5 and 20/3. I'm going to bring the common denominator back to the common denominator, and the common denominator is again 15. So here I have a 3 and here I have a 5. The result is, let's write here, and I end up with 93/15 and 115. Obviously, I will have more 115ths than 93/15. Here's another way to compare mixed numbers. In the next lesson, we'll look at a couple more interesting examples. And that's all for today. Goodbye. See you again.